In this question, we're given that a function is defined from natural numbers to natural numbers, and the definition is fn is equal to n plus 1 if n is odd, n minus 1 if n is even. So for n is equal to odd numbers, you have a different definition. For n is equal to even, you have a different definition. These type of functions are called piecewise defined functions. So these are called piecewise defined functions. That is, for some numbers you have a definition, for other numbers you have another definition. You might have 3 different definitions also, or 4 different definitions also. So you're asked to prove that f is invertible. So first let us draw the diagrammatic form of this function and convince ourselves that it is an invertible function before trying to prove it. So if you have, I draw a function like this. Let f be the function defined from natural numbers to natural numbers. 1, 2, 3, 4, 5, 6, so on. 1, 2, 3, 4, 5, 6, so on. Now, if n is odd, the functional value is n plus 1. So for 1, it is 2. For 3, it is 4. For 5, the functional value is 6, so on. So if you take an odd number, it will be connected to a number which is 1 above this number. Now, if you take n is even, the image is n minus 1. So 2 is even, the image is 2 minus 1, which is 1. If you take 4, the image is 4 minus 1, which is 3. 6 minus 1, which is 5, so on. So this is how the function looks like. So do you see that this is 1, 1 function? As you can see, different elements have different images. And all the elements in the second set are being mapped. So 1, 1 and on 2 seems to work in this. So now let us prove it analytically. First, 1, 1. So what should you prove for 1, 1? For all x1, x2 belongs to the domain n, fx1 is equal to fx2 should imply x1 is equal to x2. So this is what you need to prove. Now, here you have a piecewise definition. So if you assume x1, x2 in the set of natural numbers, so different elements might have different definitions. So you cannot directly write what f of x1 and what f of x2 is, because fx1 and fx2 depends on whether the number is even or odd. So what we do is we take different cases. So take let x1, x2 belongs to natural numbers. So there can be 3 cases. Either both can be even, or both can be odd, or one can be even and one can be odd. So these are the 3 cases that you have with respect to 2 natural numbers. So case 1, let x1, x2 both be even. So now f of x1 is equal to f of x2 means that because x1, x2 are even, this definition works. So x1 minus 1 has to be equal to x2 minus 1. Minus 1 and minus 1 are getting cancelled. So x1 is equal to x2. So if both are even, f of x1 is equal to f of x2 implies x1 is equal to x2. Similarly, let x1, x2 both be odd. So now let us assume f of x1 is equal to f of x2. So what does this imply? x1 plus 1, x1 plus 1 is equal to x2 plus 1. These two are getting cancelled. This implies x1 is equal to x2 again. x1 is equal to x2. Now third case, let x1 be even and x2 be odd. That means one of the number is even, the other number is odd. So f of x1 is equal to f of x2. So this implies, what is f of x1? Because x1 is even, so x1 minus 1 is equal to x2 is odd, x2 plus 1. So this implies, you can see that x1 minus x2 is equal to 2, which is not possible, because the difference between an even number and an odd number will never be an even number. So if f of x1 is equal to f of x2, x1 minus x2 has to be equal to 2. x1 minus 1 is equal to x2 plus 1. So x1 minus x2 has to be equal to 2, which is not possible, because 1 is even and 1 is odd. The difference will always be an odd number. That means the condition that f of x1 is equal to f of x2 is not possible if one number is even and one number is odd. So the 1-1 condition says that if this is possible, then this has to happen. Here it has been concluded that f of x1 can never be equal to f of x2, so there is no problem with the function being 1-1. Hence, in all cases, 1-1 nature has been proved. Hence, f is 1-1. Now, let us go forward and prove the onto nature of this function. Now, the proof for onto nature. So, to prove that a function is onto, what should you prove? For every y belongs to the second set, there is at least 1x in the first set, such that f of x is equal to 1. So, we'll start with let a number n belong to the set of natural numbers. Let a number n belongs to the set of natural numbers, which is the codomain. Now, you have two cases again. The first case is this number can be odd or even. So let n be odd. Let n be odd. So for every odd number, there exists a corresponding even number n plus 1. So for every odd number n, there exists a number n plus 1, which also belongs to the set of natural numbers, right? So every odd number plus 1 is always a natural number. Every odd natural number plus 1 is always a natural number. So belongs to n. If n is odd, this is even. So if n is odd, there exists an n plus 1, which is an even natural number, such that f of n plus 1 is equal to, because n plus 1 is even, this definition works. So n plus 1 minus 1, which is equal to n. So f of n plus 1 is equal to n. So if n is odd, there is a number n plus 1 in the first set, such that f of n plus 1 is equal to n. Hence, for every odd number, you have a pre-image. Let n be even. There exists a number n minus 1, which belongs to the set of natural numbers, and n minus 1 is an odd number, such that f of n minus 1 is equal to, because n minus 1 is an odd number, this definition works. So n minus 1 plus 1, which is equal to n again. So even if n is odd, you have a pre-image. Even if n is even, you have a pre-image. Hence, for all n belongs to natural numbers, there exists a corresponding, let us say x, which belongs to the set of natural numbers again, such that f of x is equal to n. Hence, the function f is onto. So if you are given an essay question for your board exams, you just need to write whatever is written here. Thank you.